So from the last video we did the Laplace of e raised to power 80, that means Laplace of exponential functions. Now we're going to this, which is Laplace of hyperbolic functions, which is sinh of kt and cos of kt. So to find Laplace transform, there are many ways to do that, but the easiest way is to express the hyperbolic function in terms of what? Exponential function. Since we know the Laplace of the exponential function, then that makes it more easier for us to find the Laplace of this by expressing this this um in terms of this expression, more clearer and easier than finding the direct Laplace of of this. So, and we know from the definition of sinh is equals to what? E raised to power whatever is here, e raised to power this minus e raised to power minus of this over 2. That is the definition of sinh. Definition of quotient of cosh is what? Is plus. So you put plus instead of minus over what? Over 2. So finding the Laplace of this are very easy. I'll be starting with the Laplace of sinh. From the definition, the Laplace of that of sinh of kt equals to Laplace of this expression, which is equals to e raised to power kt minus e raised to power minus kt over 2. And this is a constant, and we know in mathematics when you're dealing with integration and differentiation, you can bring the constant outside. The same thing happens here. Since Laplace is an integral transform, you can bring the constant out of the integral. So therefore, I can bring the out here, and I'll be left with Laplace of what? E raised to power kt minus e raised to power minus kt. So this is how to get, and so I have to find this and I have to find this. But fortunately for us, in our last video, we found the Laplace of this. So let me write everything independently. That will be Laplace of e raised to power kt minus the Laplace of e raised to power minus kt. So the Laplace of this, note, the Laplace of this in our last class will be equals to 1 minus s minus k in our last class. Also, the Laplace of e raised to power minus kt will be equals to 1. So think of this minus k as a constant also. Minus k is also a constant. Instead of k, replace minus k. That means this k here will be minus k. Minus k. And now equals to what? 1 over s plus k. There's a trick here. Anytime you have Laplace of exponential, whenever you have positive, that will be negative. Also, whenever you have negative, just change to plus. You can see what happened here. You can see when I put the minus here, it multiplies this and gives plus. So generally, anytime you have negative or a negative constant, it will be x plus k. And anytime you have a positive constant, it will be what? X minus k. That is very easy to. In fact, I'll be dropping a video on tricks on how to remember those formulas. So you can see what I did here. I expressed this, which is normal expression, and we relate to this, and I placed Laplace for this individual. So I took the L of this and the L of this, which is what I did here. But we know from the last video that this is equal to this and this is equal to this. So that makes my work easier, and that is the Laplace of sinh of kt will equal to half of 1 minus 1 over s minus k is 1 over s minus k minus 1 over s plus k. From there, that will be half. That will be half. So taking the LCM of this, I have s minus k multiplied by s plus k. This, and this whole expression in this expression is this multiplied by 1, that is s plus k. This and this is this multiplied by 1, which is this. So that will be s plus k. You can open this and that is minus k plus k over. Now here, when you do this, that gives us x squared. And this is also known as the difference of 2 squared in mathematics. This is what we call the difference of 2 squared. You have the x squared and you have the minus k squared. When you expand all of this, you end up having this. I'll do it over there. So okay, let me try to explain how I got here from this place. How I got here. X minus k multiplied by s plus k. That gives x squared plus sk minus sk minus k squared. This cancels out this because they are the same. So you are left with what? X squared minus k squared. And that is also the famous difference of 2 squared in mathematics. So that's the reason why I was able to identify quickly that this leads to this immediately. Now continuing what I was doing before, I have an half here. So that means my answer will be equals to half. Now this cancel this. Sorry, this minus s cancel this minus this s, and that becomes 0. So you're left with k plus k, which is what? 2k. You can see what we have there. This cancel this. So you have left with 2k, and the 2 cancel this 2. So that will be k over x squared minus k squared. That will be my answer. You can see this is very easier than finding the Laplace transform of this directly. That is very hard. Also, the same goes for the Laplace of this. So let me call it B. The Laplace of this, which is equal to Laplace of e raised to power kt of 2. Plus. Now here, the difference here is that sign is defined as minus, but here it's defined as plus. So that is Laplace of this plus Laplace of this. So what's Laplace of this? From what I've said before, that is 1 minus sk, and this is s plus k. So the LCM here is also s minus k, and the LCM here is s minus k multiplied by x plus k. So this in this is this. Because you take this out of this whole, you have this. And you take this out of this, you have this. Plus s minus k. So that gives us half. And this cancel this. So you have 2s over what? As I've said before, this equals to what? X squared minus k squared. So the 2 cancel this 2, and look at what? S squared minus k squared. So that will be the answer. That will be the transform of what? Of course. So since we're able to prove the two hyperbolic function, then we can what? We can write it down. So generally, the Laplace is equals to k over x squared minus k squared, and the Laplace of cos is equals to s over x squared minus k squared. So that will be the general formula for what? Laplace of this. That will be the derivations. So the value you got after looking for the what? The Laplace of these two functions. So this will be the what you get, which is a function in terms of s. So on this, you can want to play with certain things like the Laplace of sin. Now this k is a constant, so that's why I have sin 60. 6 is a number here, so my answer will be 6 over x squared plus 6 squared. Simple as that. Also, if I had Laplace of cos 20t, that will just be s over x squared. Here is minus. There is a mistake. Minus. You can see there's a minus there. There's a minus here. This is minus, and here is minus 20 squared. That will be s over s squared minus 400. That will be Laplace of this. So this k that I've been using in all the videos, you'll be seeing the constant of what? Of the functions, inside the functions. But the t is the t in the divine for the function. So this 6 over, so yeah, that's 6. So that is how to use the what? Use the Laplace. So I think these are the elementary functions that we need. And the other functions that we have are those what? Are those, you don't need to go to hard processes. We have theorems to do that. The other complex functions, we use theorems like the phase shift theorem, like the derivative of transforms, and all that, as well basically others transforms of complex functions. But for now, enjoy this.